Welcome everyone, I'm Brian Walsh, and in today's lesson we're going to go over how to write molecular, ionic, and net ionic equations.
Let's start by looking at the molecular equation. So the molecular equation shows all the reactants and products as if they were intact, undissociated compounds. Let's take a look at an example to see what we mean by that. So this problem says solutions of barium nitrate and sodium carbonate are mixed, and solid barium carbonate and aqueous sodium nitrate are formed. Write the balanced molecular equation. So remember, when we write our equations, we're going to look for key words to help us figure out what our equation is. So this tells us that barium nitrate and sodium carbonate are mixed. The mixed tells us that sodium carbonate and barium nitrate are our reactants. Then it tells us that barium carbonate and sodium nitrate are formed. And the formed tells us that sodium nitrate and barium carbonate are our products. So now we have our reactants and we have our products, and now we need to balance it. So we have one barium on the left, one barium on the right. We have two nitrates on the left, and only one nitrate on the right. So we put a 2 in front of sodium nitrate. Now we have one barium on the left, one barium on the right, 2 nitrate on the left, 2 nitrate on the right, 2 sodium on the left, 2 sodium on the right, 1 carbonate on the left, and 1 carbonate on the right. So now we're balanced. Our problem tells us that we have solutions of barium nitrate and sodium carbonate, which tells us that this is aqueous and this is aqueous. It says that we have solid barium carbonate, which means that barium carbonate is a solid, and aqueous sodium nitrate, which means our sodium nitrate is aqueous. And we can see that all of our molecules, all of our compounds, are intact, which tells us that this is our molecular equation. Because our molecular equation has intact, undissociated compounds, just like this. Now let's look at the total ionic equation. The total ionic equation shows all of the soluble ionic substances dissociated into ions. So our molecular equation looked like this, right? All of our compounds were intact. None of them were dissociated into ions. For the total ionic equation, anything that dissociates into ions, we have to write as ions in our total ionic equation. So because barium nitrate is aqueous, it's going to dissociate, which means that we have our barium ion, which is a 2+ ion, and we have 2 NO3- ions. And the 2 here on the nitrate comes from the 2 right here. So this 2 tells us we have 2 nitrates and only 1 barium. We can see that sodium carbonate is also aqueous, which means this is going to dissociate to ions also. So we have 2 sodium ions, and our sodium is a +1 charge. So we have 2 sodium ions here, 2 here, and we have just 1 carbonate ion. So our carbonate is a polyatomic with a 2- charge. Now we can look at our products, and we see we have barium carbonate here, and barium carbonate is a solid, which means that this is not soluble. So this is not going to dissociate into ions because it is not soluble. So in our total ionic equation, our barium carbonate stays the same. Next we have sodium nitrate, which is also aqueous, which means this will dissociate. And we can see that we have 2 sodiums here, so we have 2 sodium ions. We have 2 nitrates, so we have 2 nitrate ions here. So this gives us our total ionic equation. And last, we're going to look at the net ionic equation. So the net ionic equation omits the spectator ions and shows only the chemical change that's taking place. So the spectator ions are the ions that don't participate in the reaction. So we've already seen that our molecular equation looks like this, and our total ionic equation looks like this. So the way that we find our net ionic equation is we're going to go through our total ionic and eliminate all of the spectator ions. In other words, we're going to go through and find the substances that are the same in the reactants as they are in the products. Because if they're the same on both sides, it means they did not participate in the reaction. So we can see that barium is not the same on both sides, right? So barium does participate in the reaction. Now we look at nitrate. So we have 2 nitrate ions on the left, and we have 2 nitrate ions on the right, which tells us that our nitrate ions did not participate in the reaction, which means that they're spectator ions, and they're not going to show up in our net ionic equation. We look at sodium, and we see that we have 2 sodiums on the left, 2 sodiums on the right. So sodium didn't participate in the reaction either, which means that sodium is also a spectator ion. Finally, we look at carbonate, and we see that carbonate is different on the left than it is on the right. So carbonate did participate in the reaction. So we're going to omit the spectator ions, meaning we're going to get rid of these. And when we do, what we're left with then is the net ionic equation. So you can see that all we have left is barium, barium, carbonate, and this is that carbonate, and then barium carbonate and barium carbonate.
If you have any questions about anything, or if you have any feedback that you'd like to give me, please leave me a message. You can leave a comment, or you can email me at chemistrymadeeasy118@gmail.com. Thanks for watching.